Beyond Emissions. Welcome to another great podcast episode of Beyond Emissions. Our special goal, our mission, is to create a world that is beyond emissions. And that doesn't mean 100% electrical. There's lots of ways we're going to get there. As you can tell, we're very diverse in our thought process about how we're going to create this world that is beyond emissions. We're so thankful. Regenerative farming, Will Harris from White Oak Pastures recently on the show, talking about how farming in a regenerative fashion actually can help mitigate climate change. I mean, there's so many different ways that we're going to get there. But first, before we have our guest on today, our very special guest, my friend, Dr. James Clegern. He is the founder, the CTO and president of a company called Kineticcore Flywheel Energy Storage. Oh my gosh, this is going to be a great show today. Reinventing the wheel of sorts, you know. So we're excited to talk to Dr. J here in just a moment. But let's get into real quick the premise of our program of Beyond Emissions, creating a world that is beyond emissions, an emissions-free future. What does that look like to you? What does that mean to you? Be a part of the conversation. Like this video and subscribe. Beyond Emissions YouTube channel. That's Beyond Emissions YouTube channel. Click that reminder bell in the corner as well so you can continue to be a part of this ongoing conversation. We want to hear from you in the comment section as well. How do you think we can get there? But also as well, what does the world look like that is beyond emissions? Matter of fact, I like to ask that of our guest every time that we start the broadcast. So let's introduce him right here and right now. Dr. James Clegern from Kineticcore. Welcome to Beyond Emissions Podcast.
Thank you, Joshua. I appreciate the opportunity to come talk.
It's been great to get to know you. We chatted a couple weeks ago, and it was just to say hi and get to know one another, not necessarily to have a program. But boy, we just got off on a great conversation for over a half an hour. And I was just so thankful to learn more. And I was like, we've got to get you on Beyond Emissions to talk to our listeners about this amazing new technology from Kineticcore. Dr. James Clegern, President, CTO of Kineticcore Flywheel Energy Storage. And we'll talk about that in just a moment. That's kind of the how we're going to get to that world that is beyond emissions. That's part of the how. We're going to do it, the technology that it's going to take us to get there. But what about the why, which is what does a beyond emissions world look like? In your mind's eye, Dr. J, what does the world that is emissions free look like to you overall?
Well, it's going to be a combination of multiple different technologies, all of which will be tackling, production, prevention, recapture. We have, no one particular solution that's going to be able to do everything. And so that's really important. And we, the beyond emissions standpoint is once the technologies start really coming into their own, we can really make a dent into the whole CO2 climate change gases that are going out and hopefully be able to reverse the, I would say, battle damage we're doing to Mother Earth and bring the pollution back into check so we can get into better balance.
Right. There is a natural carbon cycle. Carbon is a natural part of the life cycles on planet Earth, right? It's not a poison per se in that, that through photosynthesis, plants breathe in carbon. And I mean, we're made of carbon. So demonizing carbon necessarily isn't what we're doing, but bringing it back into balance. Decades and decades of pumping millions of barrels that have been stored in the ground for millions of years up into the atmosphere is out of balance, right? My friend Brooke Hanner, my mentor in the renewable energy business from Offline Solar. By the way, go there, folks, and check it out, offlinesolar.com. Brooke talks about it in the way of saying, Equilibrium. Energy is always seeking equilibrium, but he says, you know what? That's just a fact of life. And we're way out of equilibrium right now in our environment as it pertains to carbon, right? Would you agree?
Definitely. You really got to look at it, how much we've been pumping out since the Industrial Revolution 200 years ago. We've been basically shifting that balance for what the Earth can naturally absorb or continue in its self-contained cycle. And when you get out of balance and it can't handle that, then you either have a reaction like we have with climate change, and we need to do something about it.
Right. What happens if we eat, nothing but sugar all the time, and we just deliver nothing but pure cane sugar to our body 24/7 and nothing else, right? What happens? We don't die immediately, but all the systems start to go downhill. We're very, very resilient beings. God created some really amazing hardware when creating us in his image. So definitely very resilient. But out of balance, before you know it, people start getting plaque in their arteries and they die prematurely, and all sorts of other obesity, all sorts of other health issues. Why would the other parts of creation not work the same way? It's all about balance. And I believe that not only is it about the environment, but a world that is beyond emissions. And you can speak to this, Dr. James Clegern, President and CTO from Kineticcore on Beyond Emissions podcast with us today. In regards to everything else that's going to benefit by bringing that balance back to our emission structure here on planet Earth. So if we have a world that's beyond emissions, not only are we going to mitigate climate change and reverse even some of the negative effects, but what about national security? We're solely dependent right now, the reserve currency status of our dollar being backed by oil, basically, since we got off the gold standard, right, Dr. J? And now you see China with the yuan and Saudi Arabia looking to trade in the yuan instead of strictly just dollars. We have to diversify our energy structure to save our economy and our national security as well, which could bode, in other words, a world beyond emissions isn't just the environment. It's national security, it's world peace. There's a lot of other factors that will benefit on planet Earth besides just the environment, right?
They all are linked. So, from the national security standpoint, if you can't get access to the minerals that you need to be able to do the pieces, that becomes an issue. If you're reliant on other parties to provide the energy capability, with be it carbon-based or whatever, then that becomes an issue. And it's a combination of a balancing act, not only from the environment, but from the national security and other pieces that bring those parts together.
Yep. And again, the key word is balance. The word of the day is balance. It's so true. And obviously, this is the vision, the dream we have at Beyond Emissions and creating an emissions-free future. That's the why, right? Start with the why, Simon Sinek, and then you go next into the how, the mechanics. How are we going to do that? Well, great technologies are on the horizon and exist right now today. There's also some ancient technologies that we're going to bring to bear. Kineticcore has reinvented the wheel, if you will, right? So flywheel energy storage is not a new thing, right, Dr. J? Talk to our audience, please, about the history of flywheel energy storage, and then we can get into how Kineticcore is revolutionizing that wonderful technology to bring to bear solutions today to get us beyond emissions.
Certainly. Well, if all of us remember our history lessons, the ancient potters used a wood potter's wheel as a means to do power smoothing, so they could collect clay pots in a controlled manner. That was one of the earlier examples of using flywheels almost 4,000 years ago. And over through the ages, the flywheel has been one of the primary components with regard to power storage, power dispersion. As we go all the way up to a miller's wheel on a windmill is another example of a flywheel, and all the way up into the Industrial Revolution, when flywheels were able to smooth out the power transfer from the new steam engines that were coming on board. And during that time frame in the late 1700s, flywheels were really optimized when they were able to make consistent steel to have a flywheel that would operate without having the possibility of a failure. So for the last 200 years, those cylindrical steel flywheels have been pretty much the mainstay for flywheel energy storage, and the technology really hasn't advanced. Lots of folks have been able to do improvements on subsystems, better bearings, better high temperature superconducting, better electronics, but the core to the flywheel hasn't changed much with regard to technology in just about 200 years. So what Kineticcore is bringing a evolutionary jump to flywheels is making an improvement on that flywheel structure and taking us away from a traditional cylinder to a three-dimensional shaped flywheel that allows us to do higher speeds, and it's designed to be used with the carbon fiber instead of traditional steel. And that whole piece allows us to shift flywheels from a kind of a niche piece that's rather expensive to something that is now competitive with lithium-ion batteries and has all the advantages that flywheels bring to the table. So we have we have the ability to have literally unlimited power cycles per day for operations. We last 25 years, so you have no battery replacements. And for our particular system, we have no chemicals in it at all, and it's a very straightforward, simple design that implements this new structural capability.
Yep. The size, the mass of traditional flywheel technologies utilized to discharge energy generally have had to be so huge that it's not effective. And so therefore, you mentioned it, niche. It's been just a niche product for certain small segments of the market, whereas you have figured out a way, and your team there at Kineticcore, to bring down the mass and still make it go faster and deliver the energy needed for the customer. What an amazing adjustment. Nobody's looking at it like that. What inspired you to take that leap of faith?
Well, what it really comes down to is up until about 20 years ago, flywheels were one of the most efficient and cost-effective means for doing high power smoothing and starting to look at energy storage. When the when the chemical batteries like lithium ion have finally come down in cost, they are now the go-to because they are less expensive upfront to deploy. And that's where a lot of the folks are like, hey, lithium is the thing to go for, which until you can get the price down, you're right. The upfront cost is what drives most of the folks' decisions with regard to bringing in energy storage. And what Kineticcore is able to do is, by having a much lighter weight flywheel that spins faster, the weight of the flywheel is directly related to how much it costs up front. So if we can drop the mass of a effective flywheel by a factor of 10, the cost that drops is about a factor of 5, which puts us right in competition now with lithium-ion batteries. But lithium-ion batteries have all the disadvantages of a chemical storage system. They do wear out. They have, the uncontrollable fire modes for failure that many of us have seen on the news. And they're becoming more and more difficult to get access to as more folks are wanting the lithium batteries, and the supply chain to be able to provide them just right now cannot keep up.
Wow, that's amazing. That's amazing because this is an ancient technology, and now it's a solution, especially with the advent of the electrical vehicle and the charging requirements. These mandates for electrical vehicles coming to be produced in California, no more internal combustion engines sold after 2030. I don't know if that's realistic or if they'll grandfather some folks in, but at the end of the day, that's the direction we're headed. And our grid is not ready for it. We don't have enough charging stations. And even if we did, our grid is antiquated to the point needing so many upgrades, it's just not possible. Well, my friend from Allen Systems, DC to DC optimizers and converters, Allen Systems over in Pennsylvania, they partner with a lot of big companies on grid scale projects. And Hanan Fishman, their president and CEO, has created some great writings and white papers on the gas stations of the future, and how the key and the solution to this problem of electrical vehicle charging and creating more charging stations is actually by creating a lot of independent systems with energy storage paired with renewables to deliver the power needed right there on site. So we're not having to tax a grid that's not capable of handling this type of growth in that area. You mentioned on the phone the other day that Kineticcore can play a key part of being a solution in this area, especially for folks who only have 120, 240 split phase, let's say, but they need to have to be able to bulk charge. Because raise your hand if you want to stop off and charge your car in 4 hours. Don't have the time. We need to be able to get it done in 15 minutes, right, Dr. J? Kineticcore, a big plus for that, right?
Yes, it's one of the key areas that we are looking to do support, because kinetic batteries in general are really well designed for stationary applications. We are not your battery to be put into an electric vehicle, but on the flip side, any of the electric vehicles want to have the fast charging infrastructure in place, because that's how you're going to increase adoption. So the fast chargers also need to be focused on with regard to energy storage. And a kinetic battery paired with a DC fast charger provides a really good solution that allows the other chemical battery solutions that have been employed so far to be shift that lithium over to the mobility side, and don't bother wasting lots and lots of stationary lithium batteries on a charging system that we can do the job as good as or better and last 25 years instead of having to be constantly replaced as the batteries wear out.
Yep. Yep. Exactly. Kineticcore President and CTO, Dr. James Clegern, here with us today, discussing flywheel technology. Kineticcore solutions can also help with peak shaving and they've decided to do the lawn outside, folks, so please forgive me. I'm going to continue on anyway. The show must go on. So in regards to energy storage and utilizing flywheel energy storage technology like Kineticcore, peak shaving and demand charge relief, especially for commercial and industrial customers, that's a big deal too, right?
It sure is. It all falls under what we call peak load management. Boosting fast chargers is one aspect of that capability. The other aspect is being able to support commercial and industrial facilities that have high peak loads. And flywheels are very well suited, especially our kinetic batteries, to support those type of capabilities. And so we're looking at a 4 hours or less application where they need to have peak load management. And if you combine that with a solar microgrid, for example, on that commercial facility, we now have the capability with our kinetic batteries to be able to do peak load management, smoothing of the solar power for ramp rate control, as well as being able to store up and then shift 4 hours of energy later in the afternoon during peak times. And the battery is specifically designed to be able to do all three of those applications, whichever is required at the particular moment in time during the day.
And unlike chemical energy storage like lithium iron phosphate, where you're basically charging it up once a day and then discharging it over whatever period of time is desired, you've got 4 hours of discharge with the flywheel technology from Kineticcore, but you're not digging into your life cycles and shortening the life by recharging it and then discharging it multiple times per day, right? How often can it be recharged in one day, whether by renewable energy sources or even by power available at night when the rates are cheap from the grid? Lots of really flexible options here with flywheel technology versus chemical energy storage, right?
That's correct. Essentially, you have unlimited power cycles per day, all dependent on how the customer wishes to use them. We could do 24 30-minute charge and 30-minute discharge cycles per day, so basically one full cycle per hour over 24 times a day. Or you can shift it down to 6 4-hour, smaller blocks of time to be able to use the system. It's really limited based on how much time you have available and what your power source is.
And that power source, there's flexibility there as well, right?
There is. We can tap, a 240 single phase line coming out of the wall from that's pretty much available anywhere, all the way up to however much 480 three-phase that you can provide. The advantage there is that if your facility does not have access to the high power, we can still tap the lower capability and provide the peak management for, high power requirements.
That's awesome. I just watched a webinar the other day. Solarc is an inverter I love, and they're expanding to commercial and industrial with a 30K and a 60K. And on the DC side, for the 30K up to 500 volts DC, 150 to 500, and then on the 60 up to 800 volts DC for the battery side. And it's just amazing how it has the ability in a commercial and industrial application to AC couple into an existing system. A lot of these big commercial food processing plants, ag centers, industrial centers, they've invested a lot of them in solar during the day, grid tie only. And to come in with energy storage at such high voltages is really, really dangerous in some scenarios. And oftentimes there's not a compatible battery-based inverter system that can really make it happen as well. Flywheel energy storage technology from Kineticcore paired up with, say, Solarc's 30K or 60K inverter that can AC couple to an existing commercial or industrial solar system that's grid tie only currently. Wow, that just opens the door for a lot of these customers to really lessen their bills, really start to make their costs predictable over the life expectancy of their already made investment. How amazing is that? Technology, not just in your realm, but in what other people are doing. I see you being able to work Kineticcore and Solarc and other types of technology like that to help a lot of people in that world.
What it allows you to be able to do is pair a 25 or 30-year renewable package with a energy storage system that also has the same lifespan of 25 to 30 years. Then to top that all off, kinetic batteries are designed such that you buy them once for the same price that you would a lithium battery pack, and we last the full extent of your project, all 25 or 30 years. And then top that off with the proper bidirectional inverter, your system now can become a distributed energy resource for the grid itself. So if you have extra, you can actually send it back out onto the grid, get a little extra income from that standpoint, and provide an additional service to the greater grid community.
Right. Overall grid resilience, which is the key. And that's why dispersed energy storage, not just a gigantic farm out in the middle of somewhere that's ran by the utilities. That's good too. But having dispersed energy storage everywhere is what makes it a real benefit for resiliency for the rest of us when we have grid outages, et cetera, or we need extra power at times where there's a lot of taxing on the grid at that moment. We've all been there at the summertime during the brownouts, during the grayouts, whatever you want to call it. Now, you mentioned life expectancy being the same. I think you're being a little too nice to chemical energy storage, of which I love. I love all forms of energy storage. I'm not biased here. Definitely today we're spotlighting Kineticcore and your Flywheel energy storage technology. I think it's amazing. Dr. James Clegern with us today here at Beyond Emissions. Like the video, subscribe. But you're being a little too nice because you have a little bit more information in your back pocket. I'd like you to talk a little bit about this other factor. It's more than just the same life expectancy at 25, 30 years as a properly sized lithium iron phosphate system, for example. There is a big difference, though. At the end of life for lithium iron phosphate and other forms of chemical energy storage, generally there's a degradation. There's a loss of capacity. At the end of life, you generally will have 70 to 80% of the original capacity still available, and 20 to 30% at 25 to 30 years has vanished. That's a little different with Kineticcore's Flywheel energy solutions, right?
That's correct. And just a minor clarification. I was referring to the microgrid infrastructure of the solar and the power electronics of being 25 to 30 years matched to our battery system that give you the 25 to 30 years. Most of the chemical battery systems, especially lithium ion, you have warranties that allow you to do up to 10 years, and that's assuming that you're cycling once a day. And almost all of the chemical battery systems do have that degradation. The advantage with regard to kinetic batteries is that the faceplate that you install is the same one that same capacity and capability that you then retire, 25 or 30 years later. We do have nothing that degrades. We have no chemicals that wear out. And the other bonuses is that you're fully recyclable. I mean, our systems are basically made out of steel and carbon with a few trace elements to make the electronics work. So not a whole lot there with regard to have to worrying about recycling, for example.
Wow. So for the long term, your customers of Kineticcore Flywheel energy storage technology spotlighted today here on Beyond Emissions, your customers actually can look at it from the standpoint that it's repairable. Is that true?
We have very low maintenance designed into the system. So, a traditional monthly maintenance cycle on a kinetic battery is a maintenance person with a backpack-mounted vacuum cleaner to clean the dust bunnies off of the vent air ports that come in for keeping the electronics cool. Other than that, the system is essentially maintenance-free, except for looking at dedicated inspection cycles every 2 and 5 years.
Do we have any current, pardon the pun with amps there, current, do we have any current success stories that we could talk about and share with our audience where your system and technology from Kineticcore is currently being deployed?
Kineticcore right now, we are in the process of preparing for our pilot deployments this coming year. So all of our systems that have been under test have been in our facility here, so we don't have any actual deployments as of yet. but we are in the process of getting ready for the pilots about this time next year. And from that point forward, we are getting ready to pretty much run full sprint for the marathon that this whole exercise will be as we start getting into manufacturing.
Yeah.
Josh, just keep in mind, we're only 3 years old, but we have gone from a paper virtual design to a full system prototype in effectively 3 years, which is a really good example of what we've been able to do with the technology and proving it out and bringing it forward.
Yeah, that's leaps and bounds compared to, it's like warp speed, what you've accomplished. I'm so proud to see the results that you've created in the development of this new, not new technology, but new version of this technology. It's amazing what it's going to do to help us get to this world that is beyond emissions. Recyclability is also key. You mentioned that earlier. How huge is that? Oh my gosh, especially right now. I'm a fan of lithium iron phosphate. I don't think it's the same as some of the lithium ion batteries with cobalt manganese. I think, like you said, it's gonna slide over more so to the mobility market, not necessarily all on the stationary side. But having to mine lithium, there's one, if I'm correct, there's one place to get lithium in America right now, which is in Nevada. And it takes forever. It's like a lake that almost has evaporation going on, and to get that usable lithium, it's almost like making salt, I guess. But to get that usable, I saw it the other day on PBS of all places, talking about this one place in America where we can mine our own lithium, and it's not a substantial amount. It's minimal, and so we have to get lithium from around the world in very politically unstable places. Probably not good for the environment. I know it's out of sight, out of mind for us here in America, and we're being green, but if we could see some of those mines, we might not like what we're seeing, right? Recyclability and access to the minerals and the raw materials needed to make Kineticcore, that's a whole nother animal, huh?
It is, and just to give you a reference point, it's, if I remember correctly, it's about 20,000 gallons of water to mine 1 ton of lithium. And you're talking about a lot of environmental impact. The lithium triangle down in South America, with the Argentina, Chile, and Peru, the farmers down there have to make that choice whether they have enough water to make their crops and make a living and feed people, or mining the lithium. And, if we can keep that down with regard to not using the lithium in other applications where it's not really appropriate to use it, that'll help minimize what we have to strip out of the earth to get it.
Right. And you're utilizing James Cordray from EnerSys. He was on episode 1 of Beyond Emissions, one of my mentors as well. James talks about the principle that all the energy that's ever existed still exists, that it just changes forms, but it never disappears. And you're using energy with kinetic energy that is not taking something out of the earth. It's a process by which you're bypassing, some of the efficiency losses that happens with other traditional and conventional forms of energy use, production, and transfer, right?
Well, you end up with a different combination of what you're for manufacturing. For kinetic batteries, it's primarily, standard steel, carbon fiber, resin, and commercial off-the-shelf electronics that are being packaged together. Some of those still have some, minor trace pieces of critical elements, but not, 1,200 pounds of lithium or manganese, cobalt, nickel that needs to be put in to make the battery actually function. So from that standpoint, you have ability to drop that down and be able to not cap that level of resource. That, like we said at the very beginning of the podcast, there's not going to be one solution that does everything. It is very difficult to put a flywheel class energy storage system on a mobility platform like a car, a vehicle, or a truck. But lithium is well suited and has the high energy density to really do that. That's an excellent place where the lithium batteries really shine, where a kinetic energy storage system really is not appropriate.
Well, we're able to take renewable energy production, say through PV array, photovoltaic, for those of you in Rio, Linda, solar panels, and produce the energy needed to get that flywheel spinning, right? And then that's where that energy is stored. Hence the name Kineticcore. Don't mean to put on our class caps, if you will, our school caps, if you will. But let's learn a little bit. I know it's rewinding a little bit on our discussion, but just the basics of kinetic energy. There's a lot of energy available in this world, and capturing it via solar or wind or other renewable energy sources and storing it via kinetic energy is an amazing way to do that. Just by spinning that thing round and round and round. Like, how does that work exactly, as far as how fast is that flywheel going? And isn't it losing some momentum as it spins around, or does it kind of keep the momentum? Or do you have to just go in every now and again and just keep spinning the wheel with more, just a little bit more renewable energy to keep it going?
Well, any energy storage system, especially when paired with renewables, allows that renewable to become a 24/7 resource instead of an intermittent resource. And so again, multiple types of battery systems can do that particular job quite well. Just some are more suited for it with regard to having a smaller environmental impact, longer life, less battery replacement than others. And that's where we're bringing the kinetic batteries into the mainstream, is to be able to offer that capability that is low cost up front for when you're trying to deploy the system, and it's low cost over the long term when you're looking at, what does it cost me over the life cycle of the battery, not just when I'm buying it to first install it. Kinetic batteries, especially with our system that is a high-speed, low-mass flywheel, our lightweight capability really drops the amount of what they call parasitic losses within the batteries. All batteries have losses, no matter what they might claim otherwise. They all are not perfect machines. Therefore, they have losses with regard to the energy coming in and the energy going back out. Chemical batteries are usually better suited for long duration storage, and kinetic systems like kinetic batteries are well suited for shorter duration applications where you're going to be using them multiple times during the day. So you're not looking at having them stand by waiting to be used for many, many hours.
Right. Not for 12, 15 hours or so, but somebody could stack a few of your Kineticcore Flywheel energy storage devices, right, to be able to deliver energy over a longer period of time, I would assume.
Sure. I mean, that application can be done with any energy storage system. And it all comes down to what your costs are for employing it, and then how it is employed. Kinetic batteries are designed to be used like 20 times a day, constantly in operation. We can do 10-minute power bursts all the way up to a 4-hour power discharge multiple times during the day. most of the chemical batteries can do that if you choose to work them hard, but their available life is much shorter. So if you work them as hard as one of our batteries, you're going to be looking at replacing, say, a lithium-ion battery, every 18 months instead of every 10 years.
Let's go there. Yeah, life cycles. Obviously, we don't have to be at a certain depth of discharge to get the max amount of life cycles. You can discharge at 100% with Kineticcore Flywheel energy technology. One big advantage, right? So if I'm looking at life cycles, how many life cycles am I going to get for 4-hour daily discharge of your Kineticcore Flywheel energy storage? Approximately, about how many life cycles are we looking at?
If you're looking at a 4-hour discharge, that would be an 8-hour round trip. So 4 hours to charge, 4 hours to discharge. So in theory, you could do 3 full cycles a day. A kinetic battery is specifically designed to be able to handle 200,000 cycles. So if you kind of do it from that standpoint, you are well beyond 30 years of operational life.
Mm-hmm.
But when you have a customer that goes, well, I want to do, 1 4-hour cycle a day to peak shift or load shift at the very end of the day when my solar is fully charged, the batteries up, and the sun is going down, and the demand is ramping up for everybody getting ready to go home and going out on the town, and the peak loads all start cresting there between about 5 o'clock and 9 o'clock in the evening. So a good 4-hour shift there makes sense. But during the course of the day, if they have a solar microgrid, they may need to have, ramp rate control on that solar as the clouds go overhead. And you might end up with, 5 or 6 full cycles during the course of the day as you're controlling the solar output to try to even it out and smooth it instead of having this jagged power pulses coming through as the clouds go over your solar array. So in a realistic application, you're probably looking at, 6 to 10 cycles per day, which then will allow you to, again, be well beyond a 25-year battery life.
Right. So, and you mentioned earlier 200,000 cycles. I'm assuming one a day. Did I hear that incorrectly?
You would have a battery system that is still performing for your great-great-grandchildren at that point. But in reality-wise, our system is designed to be charged and discharged like 20 times a day for all the different applications that we could be put into. We are not, it's kind of cost ineffective to use us once a day. If you're going to go that route, go with a chemical battery, and we almost have the same upfront costs, and we just last almost forever with proper maintenance.
Wow.
But where kinetic batteries really shine is in the applications that require what the community calls short duration energy capabilities, which is the regulation capabilities for the utilities. That's for the ramping and smoothing for solar and wind applications. That's for peak management in commercial and industrial applications, where they may have a 15-minute peak where some piece of equipment comes on and drives their power usage up by 200 or 300 kilowatts, and then it drops off. But it repeats itself multiple times during the day. And in those applications, that's where we would shine, where you'd be able to support that type of peak load management, up to 20 cycles a day, and the batteries just don't give out.
Right. So if you go 20 times 15-minute burst, 300 minutes divided by 60 minutes, so 5 hours right there. So that's well an hour over the 4. So you're looking at 5 hours a day, and wow, that is amazing. And you're accomplishing so much because of how strategic Kineticcore's flywheel energy storage technology is versus chemical energy storage in this type of application.
Yep, it all goes back to what we talked about at the beginning. No one system can do everything. Kinetic batteries and kinetic um, energy storage systems in general are very good at the short duration, 4 hours and less arena. We just happen to be the lowest costing option that can still do the job as good as or better than any of the chemical batteries that are in the market right now. But we are not designed to do long duration storage. That is still the purview of chemical batteries, although some of the potential energy kinetic systems like gravity vault and pumped hydro storage, those are really good for long duration applications where that's what they're designed for.
That's amazing. That's amazing. Now, I'm also imagining, I know you said this is not the application or the space for Kineticcore Flywheel energy storage at this moment, but in my mind, getting to this world that is beyond emissions and helping homeowners out there. I know residential market isn't the market that you're serving at the moment, but in the future, I would love to see flywheel energy storage introduced at the residential level as well. I go on your website, kineticcore.com. That's with 2 C's, kineticcore.com. Go there right now, folks. It's amazing technology. You can learn all about it. Videos and explainers there. Dr. James Clegern, with us today, Kineticcore CTO and president and founder. Excited to have him here today. I'm imagining, Dr. J, that we've got heading to our world that is a beyond emissions. 100%, you're right. There's going to be a lot of different ways that we can get there, not just one silver bullet. But flywheel energy storage is definitely part of the solution, without a doubt. And I can imagine 5 to 9 p.m. At night is when most residential homeowners that have made the investment for solar, 5 to 9 p.m., that 4-hour burst is when they're getting killed. And when everyone wants to come home and plug in their electrical vehicle at night, especially when there's a plethora of electrical vehicles that are plugging in all at once, especially during the summertime when the air conditioner's on and everything else, at the residential level, that 5-hour period for these solar customers is really the most crucial. So do you see maybe either Kineticcore or another version of what you're doing to serve the residential market at some point later on down the line?
I would say the possibility always exists, and it really becomes a matter of being able to scale production of our systems. Once you get the economies of scale and the price comes down, you're looking at a capability that would be like, adding a 20-year heat pump to somebody's house, especially for new construction. Adding energy storage with a couple of those key utility components for the house, be it your furnace, your heat pump, those type of items that are designed to be there for a long period of time would make the most sense when folks are bringing things in. And since a lot of the new homes, especially in California, are mandated to have solar included in their basically construction mix, being able to have a 15 kilowatt hour to 20 kilowatt hour solar array on top of somebody's house, which is a pretty good size array, and that combined with energy storage, you would be able to have a whole house backup capability and the ability to charge 1, potentially 2 EVs at pretty much any time that you needed to without having to tax the grid. So it is possible, and we are looking at the probabilities of going that direction, but we're still a few years away being able to bring the units down price-wise to something that the average homeowner with a solar installation would be willing to work with.
Wow. And you mentioned it's safe. Just recently in Monterey, my wife and I were at the KOA campsite just down the street from where this giant battery system was installed. And I don't think they used lithium iron phosphate, which is much, much safer than lithium ion with cobalt manganese. I think that's the route these folks went. A lot of people with deep pockets have invested money in the route that has in the lithium chemistry with cobalt manganese, much more volatile, thermal runaway, cascade failure, especially for these big systems that are being installed, and fires are happening for exactly that reason. The energy density is greater, so like you said, a lot of these systems are great for mobility applications for our cell phones, but not for big stationary power storage systems. And, you know, that's one of the areas that I see Kineticcore being a champion, because, you know, all you've got to do is open up Google and type in lithium fires and it'll pop up. All you got to do is go to the news, and every single week there's going to be a system that was installed that is not safe for the community. Whereas they're never going to have to worry about safety when it comes to Kineticcore's Flywheel energy storage technology. Safety is an amazing component of what you're offering with your technology at Kineticcore, Dr. J.
Yes. You know, the advancements we've made in the structural and system design for the kinetic battery have pretty much completely mitigated any of the uncontrollable fire failures that you see with the chemical batteries, and also mitigate any of the I would say explosive destruction problems that older flywheels have that are all steel. They have when they have a failure mode, it tends to be very spontaneous and very energetic. The kinetic batteries are such with our all-composite design really helps to mitigate the safety aspects and keeps it such that you have a very controlled means, if the battery has a problem, to be able to bring the battery down power-wise and render it, stopped for maintenance to come out and take care of things. Batteries like lithium ion, when they start having a problem, it usually is a catastrophic one, and because they are, you can't put them out with regular firefighting capabilities. Most of the fire teams have to stand back and let them burn, which is unfortunately a waste of good resources.
Yeah, definitely. And how about that investment made on the behalf of the taxpayer oftentimes, or the utility ratepayers, to create these giant lithium systems? And again, they're there for a reason. We need energy storage in these strategic areas of our grid resiliency. We need it, or it wouldn't be getting built. But, that's not exactly where we need chemical energy storage. I think flywheel energy storage is a perfect player there. Imagine that investment being made. I'm sure the insurance policy that needs to be purchased for lithium ion system made out of cobalt manganese as their primary additives in the system, in the chemistry, very volatile. And so the insurance policy that they have to purchase is probably not cheap either, right?
Again, I'm not too privy to that particular world. But you still have to insure it against, possible failures. And those are things that need to be dealt with. And, one of the areas that's from the utility side is you got to keep in mind is, the earlier lithium batteries were, developed, designed, back 15 years ago and have been slowly getting implemented by the utilities. The lithium iron phosphate batteries, which are a little bit safer, and other things, those have really been coming into their own probably about the last 10 years. and starting to make great inroads for their improved safety. And flywheel systems have also been around, but they've just been too costly to really be able to be implemented. And we are bringing a change to that, bringing the cost down to where they now could be implemented in some of the bigger projects. But we're probably looking at least another 5 years of slowly building up to that capability before the utilities are really looking forward to being able to put them into play, except for maybe, pilot locations.
How exciting to be a part of this energy storage revolution. Dr. James Clegern, President and CTO, Kineticcore. Kineticcore, there's 2 C's there. Go to Kineticcore.com today and learn more. And of course, stay tuned to Beyond Emissions podcast. I'm Josh Brum, your host. So happy to have you here today, Dr. J. Thank you very much for sharing with us this new wonderful technology from Kineticcore. Amazing flywheel energy storage technology, reinventing the wheel of sorts, if you will. How amazing. And in addition, it's a technology that's ready to go into service here pretty soon and start changing, the world as we see it, so that it could potentially be a world that is beyond emissions. I know that's a big part of why you're doing it. You also love helping people. Your mission at Kineticcore, talk a little bit about that and a little bit about your company and how folks can contact you.
Well, the easiest route for contacting us is actually through the website. And we've got folks that are, looking for strategic partners. We have folks that are looking for integrators. We have folks that are looking for bringing in and accelerating the capability. And we're looking very much for engaging with any folks in those areas. We are here based in Loveland, Colorado. And our primary goal is to bring a cost-effective, chemical-free alternative to lithium-ion and other chemical batteries that are able to be deployed to the customer's site and then have the long operational life, and you never replace us. So we happen to be looking for that solution for a long duration, buy it once, this is what you need, especially if you're looking at 4 hours and less applications.
Outstanding. Dr. James Clegern, founder, CTO, and president of Kineticcore. Kineticcore.com. Go there today, folks, and learn more. Kineticcore.com. Dr. J, thank you so much for joining us today and sharing, and we appreciate the new technology and you being on the forefront at Kineticcore and helping to bring us closer to a world that is beyond emissions. Thanks so much for being here, sir.
All right, Josh, thank you very much and appreciate the time.
You too. Hang on the line for engineers, Doctor. What an amazing broadcast today. How enlightening, how educating. I love learning. And that's why you're here as well, I know. And of course, we all share in this overarching dream to create an emissions-free future, to live in a world that is beyond emissions. Always ask yourself that as you're listening to this program. What is a world that is beyond emissions? What is it going to look like? And how are we going to get there? If you'd like to comment on that, be a part of the ongoing conversation and enter your comments into the comment section. It is Beyond Emissions YouTube channel. Like this video, subscribe, share, and also join the mission. If you've got some interesting technologies, send us a message of some of the technologies that you'd like us to spotlight here on the Beyond Emissions podcast. Thanks again for joining us. Josh Brum, your host. And until next time, looking forward to the future, a future that is beyond emissions. Have a great day.